I would like to acknowledge the invitation to be here and to present these ideas. Probably the first thing to do is to situate the problem. Really, I introduce my university. This is a small university, this is a small group working with remote sensing 15 years ago, and then working together with farmers, together with end users. Not only farmers, but public institutions, but right now focusing on farmers, focusing on farming, better than farmers. The first idea behind of this presentation is to situate the problem, to situate the challenge. The challenge probably is not the past requirements. Probably the problem for real management, crop management, to be inside of the decisions of farming is not what is the past. We need to forecast the next week or more time, as you prefer, but because we need to make decisions about next week or next days or next month. Probably we are in front of a problem. The real challenge is not the past, that is what happens next days, next weeks, next month. Okay. In this case, the problem is we need to know what is the crop water consumption for my crop next week to make decisions about what is the best moment to apply this irrigation, what is according electric schedule of taxes. I don't know here, but in my country, in Spain, the problem is you cannot use electricity in some hourly in the day. You need to use the electricity to pumping at the night or in determined hours. And water availability or my own availability. This is the problem. And then, could the satellites help me to make decision about, to know what is the crop water consumption for the next week? I would like to introduce you in this picture. This is my brother. Probably you cannot recognize me, but this is my brother. My brother is Fernando Calera. And then last Saturday, I take the picture because my brother is in charge of a family farm. It's around 100 hectares. And then rain-fed and non-rain-fed and irrigated area. And then exactly, the idea is to put on the table right now what is the real situation. He has the problem to plan what is the irrigation for the right now week. And then he requires, Alfonso, ask me, Alfonso, if you can calculate from remote sensing or using whatever thing I don't understand, really, I need to know what are my requirements, crop water requirement for the next week, because this is my real requirement, not past. Because stress, it was stress past week, it is not possible to recover. It is not possible to add more water to recover the stress. The stress passed and introduced a low yield. But I need then next week requirements. Okay, this is the situation. This farm is situated here. This is between Madrid and Valencia. This is in the deep Spain, in the plateau. Typically, our precipitation is 350 millimeters per year. And then our requirement of water for irrigation it is not possible, or irrigation is needed to obtain high yield. Then it was the forecasting. The crop water consumption for the current week will be 30 millimeters. 30 millimeters need to be translated into the hours that the sprinkler system need to work. 5 hours sprinkler system working. And then my brother, okay, I'll apply on Sunday the first 15 millimeter. I'll apply today 15 millimeter more. And according to the requirements of the constraint he has. Okay, right now the current situation of the crop is barley. We are at the stem elongation stage. And then it was our forecasting. And then he trusts because he's my brother, obviously, he trusts on my recommendation. But my brother is a farmer. And the farmer doesn't rely on me because I am your brother. No. The farmer is clear. He needs to put the finger into the water to know if the water is hot or cold. And then he required 3 or 4 years to convince that the forecasting is good. And then only I present you the previous data that he combines about the reliability of our prediction. Okay, you have there, the first idea is to introduce that it is not possible to understand a crop with one image only. This is the problem for drones. We need a time series describing the crop evolution, and probably the magic number is 1 image per week. But this time series describes the crop evolution, and then my brother seeing the images, rely on the information behind of images. Here is the quantitative information. The information is linked, this typical width, the typical curve, indicates what is in this case of crop, this is a width. This is a typical width curve by obtaining 9,000 kilograms per hectare. This is, in our area, is high yield. Probably the top is around 11,000 kilograms per hectare in another climates. And then it is possible to see this curve. This curve provides a lot of information. And then this smooth curve indicates the capability to forecast what will be the evolution knowing the previous situation. This is in the case of 2013 year. But this is the case of another typical curve described by time series of images. Each point is one image, indicating probably the parameter indicated in the axis y is the NDVI. NDVI probably is the more robust vegetation index we know right now. But the idea is to introduce differences between different parts of the plot. This is the same plot. This is in 2014. This is corn. But in this picture, in this graph, you can see 2 points. This is Landsat 8. Landsat 8 is the images. But you can see, starting in this point, both in this date, this is May 2014, red point and blue point are in the very similar situation, but pay attention because at the end of the curve, this point diverge. If in your position, probably you don't appreciate, but there is a light difference between the blue point and the red point. And then I told my brother, please, Fernando, you have a problem in the blue point. You have a problem in the blue point. What happens? The sprinkling was a failure. And then it is possible to detect some variation, but the variation, it is not given in one image. You can see one image just in the upper point, and in July, you don't appreciate. You need the time series to understand what is happening with the crop. Okay, Landsat 8 is 30 meters, but good 30 meters or good 30 meters. Good 30 meters is a very, very good spatial resolution. Okay? Because we have the images free in real time. If Landsat 8 passed this morning, here, by here, this afternoon, the image will be ready to be used. Orthorectified, perfectly orthorectified. And tomorrow morning, we can upload the image and the web into the WebGIS and to be available for farmer or for other agribusiness sector. How to do that? Okay, this is the science behind of the forecasting. This is a well-known equation that is how to know how to calculate evapotranspiration, that it will be crop water requirement. But we need to combine both two things. Satellite provides from NDVI the crop coefficient, a transpiration coefficient. This is a well-known fact. And we know to introduce weather. Weather through evaporative power of atmosphere, that is reference evapotranspiration. And then if we can forecast reference evapotranspiration, if we can forecast crop coefficient, we can forecast crop water requirement. Met Agency indicates short-term or forecasting about 1 week. 1 week is a magic number in agriculture. 1 week is the right time to make decisions. Then, for instance, Spanish Met office, Met service is providing reference IT. I would introduce the idea into the Met service here in Austrian, the idea to provide not a general weather forecast. Reference evapotranspiration is the right data for agriculture. Probably precipitation, but precipitation, the best thing is to measure in the location. But precipitation is another thing. And then we extrapolate crop coefficient from previous acquisition. This is the idea to finish. In this picture, this is real time. This is real time now. This is each blue point is one image this year, 2015. Red points are forecasting using only linear interpolation from the previous satellite data. And then we are adjusting the prediction using the previous data. This is how we are calculating forecasting of crop coefficient. And then reference IT is provided by Met service, Spanish Met service. And then we can calculate in this point, in the point indicated in the picture, we can calculate what is the forecast crop water requirement, that is around 30 millimeters. This is the idea. This is a very simple product, but we consider that this is a useful product. Who is in charge to commercialize this product? Thinking about the university is a very bad commercial element. We don't know how to do that. And then we create a spin-off, but a specific spin-off is AgriSat. AgriSat, but it is not only technicians or from the university. This spin-off, this company, this small company, involves a consultant embedded into the agribusiness sector. And then, who are the users of the service? This is the first thing, farmers. The farmers, this is a list of farms using the system, but the most important thing is not farmers in this case. The most important thing is the companies that they are using the system to provide information to his clients. Bayer, Pioneer, Alcaliver, for instance, is a company occupied to cultivate opium poppy, and this is more companies. Because this is an idea, this is a relevant idea. It's better to target farmers, target agribusiness sector around farmers. Okay, time series of satellite images, that is the first product, is very useful if we are able to put into the hands of users in real time. This is a learning of this thing. Okay, the ideas is thinking about irrigation, but irrigation is a very important part in our area. Typically one corn, plot of corn is around, it requires in our area 6,000 cubic meters per hectare. And then it's a very relevant part of the total cost production. This another idea is how expensive is this product? It's around typically €4 per hectare for individual farmers, not for companies. For instance, Bayer, the grant with us, with AgriSat, from Bayer, is providing the whole Iberian Peninsula. The total images of free images acquires in the Iberian Peninsula. In real time, it is possible to do. It is possible to display, to put into the hand the user, the end users, this type of things. And then the question is how to translate the images to the end users. Because using this type of tools, that is WebGIS, that is known as Spider, that has been developed into the previous European projects. And at the end, this question: what are the perspectives for the service to become fully operational? Okay, right now it's operational. We are in this company 2 years. This is the second year operating with these companies. Previously, it was financed by the project. It was a pilot. Okay, but what are the reflections about that? We need availability of images ready to be used, near real time. 1 image per week, ortho-rectified. It is no problem into the images from satellite or the images from drones. No problem, but I need the time series. Atmospherically corrected to avoid cloudy days. Low cost of images. Landsat Day and probably Sentinel-2 will be free. But if you require another special resolution, you need to pay. And then we need low cost. If no, it is not possible. But the most important thing probably is we need into the commercial, into the business model to involve the agribusiness sector. This is a mature sector. If this is a mature sector, to introduce into it is very difficult, because the question right now to the round table is why there are not here these companies? Why they are not here Bayer or Pioneer or Monsanto or the most important companies to be involved to supply inputs to the farms? Because they can be interested in our products if our products are good. That this is a real question. And then involvement of the agribusiness sector is clear for, in my opinion, the business model. And the cost of service need to be adjusted to the added value we provide with the service. Thank you very much.
Thanks, Alfonso, for the presentation. It perfectly closes the circle of concepts and ideas that have been discussing today. And it's a very good example of transferring from pre-operation, from development to pre-operation to operation. I have a question. How long, we met several years ago, how long did it take to get to this stage? And in your perception, why it took the time it took?
Okay, we need to, okay, my perception is we need to go a long way, and this is a long process into transform technological robust methods into operational methods. And probably we need to give several steps into this process. Just in the lunch, speaking about that, the idea is why is not introduced in the decision systems economic criteria, because farmers are not interested in, or they are interested in optimized benefits, but not probably to reach a top of production. And then if I need to apply nutrients, the idea is how much nutrients to optimize my benefit. This is the idea. And then we need, in the decision support systems, we need to introduce economic criteria, environmental criteria, probably to be effective. And then we need to give some steps in this process to have real things to offer to the farmers.
So it takes some time to get it running. I also want to reply to your question why these big key players in the agro-business are not here today. Not here today, at least in my perspective, because you need to build a critical mass first before you are able to talk to them and invite them to a round table to even consider what we are doing. And from my point of view, I'm in the phase of building this critical mass and to go to talk to them and to propose what we are doing. Integrating the final users, the farmers, the technological parts and the connection between technologies and the farmers.
Yes,
that's my point of view.
I heard the question. I need partners in this joint adventure, and the idea to introduce cooperative, I think, is perfect. Because they supply fertilizer, if I saw they supply another inputs, and they could be interested to improve the knowledge about how much fertilizer will require, how much water will require. I don't know if the channel has an authority to deliver, to do the water delivery. And then I think this is the right way, in my opinion. And then, to answering the question, the idea is to involve probably the best farmers, or the farmers interested in this type of things, that they can mobilize in the neighborhood. This is the neighborhood law. Is very important. If a farmer see what is doing the neighborhood, probably will do better than trying to convince them. And then mobilizing or introducing into this information the cooperative or agribusiness sector involved in that. John Deere or machinery. Why machinery has not been interested into our products? Because variable rate technology requires brain, requires our maps to apply. But we need to work together with this type of machinery. This is my idea. This is my proposal.
Now we need to work on this.
Yes, yes, yes.
I bring the microphone. There's a question. Just a second.
Thank you. What do you think, how much would a user pay for this service in Spain?
The price of
Yeah.
water typically is around, in our area. This is pumping, the cost of the electricity pumping. And then it's around 10 cents per 12 cents per cubic meter.
Okay.
12 cents of euro per cubic meter.
Okay.
This
Thank
is the
you.
price.
Thanks.
Just a comment to the last sentence you mentioned, why isn't a machine manufacturer in this room? Well, I think we must never underestimate the speed of development. Of course, the machinery manufacturers are thinking a lot about what are the products in the future which they should sell, and this is not only the machines itself, but the manufacturers will think about to sell service, to sell data. All of the big OEMs are building up now data platforms. If you buy a new tractor, you will be able to manage the tractor on the web platform, the tractor data, and this has also the idea behind this are also telemetry services, because you can evaluate problems in general by the tractor manufacturer and so on. So there are business models behind, and I think all the big companies are thinking about, and I don't think that Monsanto did not recognize that trend. Thank you.
Okay, I did this, I told this name exactly to do that. But this is to provoke some type of reaction. But the idea is, remote sensing is able to provide the brain for machinery to apply the variable rates. And then we need to work together with people involved in the development of this type of machinery. This is the idea. This is our partner.
It's our mission.
Okay, this is my, okay. Okay, I agree.
Maybe one comment also on the Monsanto. I'm not saying that they should be here, but I like what they are doing in North America is that they bought this company Climate Corp. And in North America they have quite good access to satellite data, less clouds at least than in my country, in most parts of Europe, or northern part of Europe. So they have this satellite image plus the weather prediction, and they are sort of managing where they put their seeds. In this way, if you talk about big data analysis and using it, it's an example where we can learn quite much from.
But but this is the real question we need to deal with this type of thing. Why NASA and USGS are providing free the images? Why? Why European sector is discussing about if this type of things need to be free or not? Why? Why it is possible to use a meteorological prediction forecasting from NOAA if it is not possible to use this data provided by a European meteorological service? Why?
George Alidis, I'm trying to speak on behalf of GEO because this is a discussion that we are always having at a high-level meeting when we are discussing why ESA and the European agencies do not provide free the data. Well, sometimes people make the difference. Barbara Ryan used to be the USGS director. She persuaded USGS to provide data free, and that's why we are having data free now from Landsat. I hope that there is a big discussion right now. I just want to stop the discussion here at a high-level meeting. And in the coming November in New Mexico, it's going to be again a discussion within the GEO conference, the ministerial conference there of what will be happening. Let's hope that will be much better.
Let's hope.